Welcome. So now we're going to write the equation of a trig graph in both sine and cosine, and this graph has a vertical shift. I chose this particular graph because it does have lots of information as well as notes with it that you can reference when you're writing the equations of sine and cosine graphs. And every one of these can be written in terms of sine or cosine. And there's, depending on how many periods they give us of the graph, there may be more than one way to write the equation. In terms of, and they're all right, and that's because the graph keeps repeating. I am going to write it in terms of sine and cosine. I will choose something that is near where all the information is. It is not going to have a reflection, right? Because if I depending on where I start, so for instance, if I started with right here on the y-axis for the sine graph, that graph would end up going down first and have a reflection. Right? So I'm not going to choose that one. Not that I couldn't, I just choose not to. So we're going to keep it in the format that we have there. Y equals a sine b of x minus c plus d, and y equals a cosine b of x minus c plus d. The things that will not change between the two graphs, regardless of where I choose to start which period I choose, the amplitude will not change. They'll be the same for whether I write it in terms of sine or cosine. The period will not change, so b will not change, and the vertical shift will not change. The only thing that changes is the horizontal shift, right? Because we have the same graph to the left and to the right for all infinity, and sine and cosine go through the same values. They just do it at different times. All right, so let's take a look. We're going to find all these pieces and then we'll write the equation. So the vertical stretch by a factor of a, it changes the amplitude to the absolute value of a, and it's reflected in the x-axis of a is negative, right? So if for instance you wanted to graph this equation and the person gave you the equation so that you were starting at the y-axis, there'd have to be a reflection. If I have a phase shift, though, I can avoid the reflection, right? But when you're going to graph, you're just going to graph whatever equation you get. However, when you are writing the equation, you can choose not to have a reflection depending on which period you choose. So we're going to write the graph of sine first. And so if I start here, actually, I just don't want them to overlap. I'm not going to have a choice. My sine and cosine are going to have to overlap. But I will choose this one. All right, so, actually, I could choose that one. But if I choose this one, the two graphs won't overlap and they'll be able to see it better. So we'll choose this one. We're going to start here. So here is the graph we're going to choose. So you see it goes up first. Right? That looks better. It goes up. It starts at the midline. I'll abbreviate that. Goes to its max. Back to the midline. To its min. And back to the midline. That is one period of sine. All right. If I chose to start at the y-axis, so here don't write this part down. I'm just going to show you, and I'll do it with a highlighter. So if I started at the y-axis, notice now I go down first rather than up. All right, I could write the equation for this graph, this same graph, by choosing that period. I don't have a phase shift, but I do have a reflection. But we're not going to use that one. So, oops. And I did not want to make 2. I just wanted to get rid of it. There we go. All right, so that is going to be the period that we choose. All right, and so now that's going to be our period of sine. I can get a period of cosine so that they don't overlap if I start right here. So cosine looks like the U. If I started over here, oops, I wanted the highlighter. If I started here instead at pi-4ths, I do have one period of cosine, but now there's a reflection. Right? So I'm not going to use that period. I could, but I'm not. And I'm going to get rid of it too. Oops. All right, how many times will I make it? Oh, no, no, no. All right. The computer's having fun with me. Now we've got 3 of them. No, 4 of them. I'm just going to come over here and do it. See? It likes to stop at that first choice. It's like, yeah, you wanted to clone this. You wanted 4 of them for some reason. I didn't want any of them. All right, there we go. So the red is sine. And the blue is cosine. And it has the max and then the midline and the min and back to the midline and then back to the max. All right. So I chose those 2 because they don't overlap. And so it's easier for us to see. So now let's find the vertical stretch, the amplitude, and we'll calculate that out. It's very helpful to do that, especially if your midline's not graphed and you have a vertical shift. But we'll calculate that out so you remember how to find the vertical stretch, the amplitude change. The amplitude is the same whether I use sine or, I forgot to label this one, cosine to find it. I'll put it here, I guess. So that doesn't matter. We'll calculate it out because the max, and you can see the maxes are all the same, the mins are all the same. And we can also see it on our graph. So A is, the max is 3 minus the, actually let's write the formula just to remind you. So A is max minus min divided by 2, so that is 3 minus a negative 1 divided by 2. That's 4 divided by 2, or 2. You can see it on the graph labeled with the A. Right, so it goes, the amplitude goes from, I need another color. How about this green? All right, you can see it right there. All right, it goes from 1 to 3, so that's an amplitude of 2. All right, so we have our amplitude for both graphs. And then B, we're going to, as the horizontal stretch, it changes the period to 360 divided by B if we were in degrees, but we're going to be in radians, which is actually nicer numbers. So 2 pi divided by B. There is a reflection in the y-axis if B is negative. We're not going to be looking at any graphs with that has a negative on B. We're going to just graph the positive. And quite honestly, if you can write it with B being negative, you can choose a new period and write it with b being positive. So, all right, so, but we are going to solve for b using the period. The period is labeled on the graph as well. I'm going to pick a new color. And so right here, that is the period. The easiest way to find the period is to, I'll do it right here, space, is to subtract the beginning of the period from the end. I'm going to choose that cosine graph for two reasons. Number one, the period was labeled there. Number two, I can see the values real clearly where I kind of, it goes off my graph a little bit on the sine. Although we have the whole graph in there, the numbers go off the grid there. But regardless of whether I use sine or cosine, I will get the exact same period length. So the period is 7 pi fourths. And if I have multiple periods graphed, I could use any of them to calculate. So 7 pi fourths minus 3 pi fourths is 4 pi fourths, which is just pi. All right. So we do need to, anytime there is a period change, it's not 2 pi, we'll solve for b. To solve, it's period equals 2 pi divided by b. But I don't know if I have enough space. Well, we'll see what we can do. Either that or I'll move it down a little bit. Get my orange back. All right, so actually, you know what? If I put this here, I think now I have enough space. So that's our equation right there that we're going to use to solve. So the period is pi, so pi equals 2 pi divided by b. We'll put a 1 there so as a little placeholder. And we'll cross multiply. So we have pi b equals 2 pi. And then we'll divide both sides by pi to solve for b. So b is 2. All right, so we have b calculated out. We have a calculated out. That was also 2. Now let's calculate out the, we're going to skip the phase shift because that one will be different depending if it's sine or cosine and depending on which period of the graph we choose. But the vertical displacement or vertical shift won't change. All right. If we have an equation and we're graphing, then the vertical shift is the is going to be up if d is greater than 0 and down if d is less than 0. Right? So it is the same sign as we see. Plus is up, minus is down. And let me check and make sure there's nothing else below that. That would be important for me to go over. So, no, the only thing there, the maximum minus the minimum divided by 2 is the amplitude. We already have that up here. All right, so let's go ahead and find the vertical shift. This is really easy to see on the graph, right? It's labeled right here. All right, that's not very clear, is it? I think my orientation's a bit off on that side. Maybe if I write in black. So right here, yeah, right there is the vertical shift, and you can see it by the line. We have the midline there graphed. Maybe I should even label that. I only labeled it min, but this whole line here is the midline. Right, and there. So we have a vertical shift here of up 1, right? So that means D is going to be a 1. This equation right here that I gave you as the extra bonus page of notes should be A, not D. D is your vertical shift. It's just how far your graph's been shifted up or down. And now the phase shift is going to differ for the two graphs. So that's probably why phase shift is not listed. Oh, it is listed on one of them. But that's not, so ignore that because that's not the phase shift I chose to use. And the reason is because I wanted to get two graphs in here. All right, we'll take this purple here. So yeah, if I chose that C, I'd have to have a reflection. I don't want a reflection. All right, so for this graph here, this is the phase shift. All right, I'm going to label that PS. All right, just so that so I can have enough space. For the other graph, and let's label it in a different color. Oh, I don't have any more colors. I guess I have to use green. For the other graph, that is the phase shift. All right, so the sine graph is the blue, is the phase shift. It's been shifted to the left. The cosine graph is the green. It's been shifted to the right. So let's go ahead and we'll write those both in under horizontal phase. So phase, I'm going to put PS. So where it says phase shift, just put PS next to it. So PS stands for phase shift. So the phase shift for the, well, it's supposed to be purple. I may as well keep the colors the same. Since I wrote with purple up there, I'll write with purple now. I think that's the purple. I have all these dots for when I make the pencil thing go away. All right, so the phase shift for sine is left. Let's see how. So this, can you see that? That is negative pi fourths. So right here where I wrote sine graph is going to be negative pi halves. So that is pi halves left. I'll move the word sine graph since I put the pen out of my hands. So if it's pi halves left, C is going to be negative pi halves. There we go. So this right here, every other is pi fourths, so that would be negative pi halves. All right, and let's do the same thing for the cosine graph. All right, so PS, the phase shift for the cosine graph. All right, so that graph is starting at 3 pi fourths. All right, so right here. So that's going to be 3 pi fourths to the right. So C is going to be a positive 3 pi fourths for the sine graph. And let's go ahead, we'll write the equations for both of these. And I think I'm going to write it down here, because I'm just going to move this down. So notice that A, B, and D will be the same for both graphs. The only thing that is going to be different is the C. So here's D, and we have the two different C's. One for the cosine graph, and I don't know why I can't find purple down here. I have to keep making dots. And one for the sine graph. All right, and I guess I haven't used black, so I'll write them both in black. So we have, and the format is right here. Whoops. We can still see it. So to save space, there's our format, and we're going to write the equations right down here. All right, so all we have to do is replace the A, the B, the C, the D. So we have y equals, A was 2, so y equals 2, sine is first, sine, and then B is 2, so y equals 2 sine 2. The C is negative pi halves. So notice there's a minus in there. So x minus a negative is going to be x plus. So if it's to the left, it's plus. So this is going to be x plus pi halves. And then the vertical shift is up, so it's going to be plus 1. And there we go. There is the sine graph. The only thing that's going to be different for the cosine graph, instead of sine, it's going to be cosine. But instead of pi halves, it's going to be, instead of plus pi halves, it's going to be minus 3 pi fourths. That's it. So y equals 2 cosine 2x minus 3 pi fourths plus 1. And there we go. So another little review of writing equations. We got to see sine and cosine on the same graph, and we wrote an equation with a vertical shift for this graph. So thanks for watching, and bye for now.